Okay, so hello and welcome to this video tutorial for E411 Statics and Dynamics of Simple Mechanisms. We have this problem here. It states three forces act on a bracket. Determine the magnitude and direction theta of F such that the resultant force is directed along the positive x-axis and has a magnitude of 8 kilonewtons. Before we crack on with this problem, it's worth stating there's a little typo in this problem. Where this really should say x dash axis, which explains why that axis exists there on the diagram. And also, if we're to assume that the force F is acting in the kind of positive region, then there's nothing pulling the resultant force down to assume that the resultant force could be acting along the x-axis as it originally stated in the problem. So that was just a little typo there. It should say x dash axis. But I'd approach this problem in the same way that I'd approach most kinetics problems that we've maybe dealt with before. I'd start by drawing a three-body diagram. So, yeah. Let's just draw that here. So we've got this force F, we've got this 4 kilonewton force, we've got this 6 kilonewton force. Let's add some geometry to this. So we've got this angle with the vertical here, this angle with the vertical here, and we've got this x dash axis. With this 30-degree angle here. Okay, so I believe we've got everything we need in that diagram to help us solve the problem. So as you may be accustomed with for more kind of beginner style problems, we can just resolve horizontally and vertically. So I can say that the sum of the forces in the x in this instance are equal to minus 4 sine 15 plus f sine of theta plus 6. Is that solvable? No, since we've got this unknown, and this unknown. So let's move on. We can also say that the sum of the forces in the y, that little thing there is pissing me off. So the sum of the forces in the y, we can say here we've got 4 cos 15 plus f cos of theta. Now, we might look at this system of equations and quickly realize that using what we have so far, this is not solvable yet. Why? Well, because we've got 4 unknowns, right? We've got the sum of x, f, theta, and the sum of y. We've got 4 unknowns and 2 equations. We have more unknowns than we do independent equations, so as of yet, this problem isn't solvable. What we can do then is we can consider what these sum of forces in the x and sum of forces in the y mean, and we can also introduce what else we know from the problem statement, where it says it literally gives us the direction and the magnitude of the resultant force. So we could say then, we could diagrammatize this, we can say the resultant force acting on the bracket here has a magnitude of 8, has a direction of 30 degrees with the horizontal, and its components are what we've defined above, right? So we could go ahead and write out more here using some trigonometry. We could say then that the sine of 30 in this context is equal to the opposite, which is sum of forces in the y, over 8. And we can say then that cos of 30 is equal to the sum of forces in the y, in x, sorry, over 8 as well. And then we can take our expressions for those components of the resultant force and just substitute them into these ideas here, right? So let's just make a little bit more room. Let's just make a little bit more room. So we can say then sine of 30 is equal to minus 4 sine of 15 plus f sine of theta plus 6 all over 8. And how should I write this? Let's say down here we've got cos of 30 is equal to 4 cos 15 plus f cos of theta all over 8. Okay, is this solvable now? Well, evidently yes, right? We've got how many unknowns? We've got f and we've got theta in this one, and we've got f and we've got theta in this one. So there's only 2 unknowns, and we have 2 equations. Okay, well that would suggest to us then we have as many unknowns as we do independent equations. So this is solvable. Let's rearrange these. So I'm just going to take all of the knowns over to one side. So I can multiply, for this first equation, I can multiply both sides by 8 and add 4 sine 15. That would look something like this. Equals f sine of theta. And same for the second equation, I can say I'll multiply. Oh, hang on, I've missed out the plus 6. Whoopsie. Let's just rub that out. Plus 6 equals f sine theta. And down here, okay, 8 cos 30 minus 4 cos 15 equals f cos of theta. Okay, now looking at these equations, I've moved all the knowns over to one side and all of the unknowns to the other. I think one way to also help us kind of simplify this problem down would be to numericize those left-hand sides. So in the case of the left-hand side in the first equation, I've just realized I made a mistake there, very sorry. That should be minus 6. So in the case of the left-hand side of the first equation, we can bung this in our calculator, we'd get something like 1.96. Doesn't have to be super accurate, equals f sine theta. And in the case of our second equation, when we bung the left-hand side into our calculator, we get 0.14. 0.14 is equal to f cos of theta. Okay, so we've got some very simple equations now to deal with. We've got this one up here. Oh, hello. Got this one up here, and we've got this one down here. This is a very simple simultaneous equations problem. Let's take the second equation and rearrange it for f. And I'm rearranging it for f so that I can then substitute that in for f in the first equation. So I'm going to take that 0.14. Oh, this whiteboard's having a laugh. So this 0.14 over cos of theta, we can substitute that in for f up here. Let's make some more room. We can say then that 1.9, we can say that 1.96 is equal to 0.14 over cos of theta sine theta. Now, you might be looking at this going, where on earth do we go from here? We've got this problem where we have theta here and we have theta here. So to rearrange for theta, well, that's going to be a little bit of a problem since there are two thetas, right? Well, this is an example of where we can bring in this idea of a trigonometric identity, which some of you might have encountered before. We could use what I believe is called the quotient identity in this context, where we understand that the tangent of theta is equivalent to sine of theta over cos of theta. So we can take this and just equivocate it to tan of theta. Doing that and dividing both sides by 0.14, we get this. And to make theta the subject here, we can just take the inverse tan of both sides of the equation. So I can say that the inverse tan of 1.96 over 0.14 is equal to theta, which is equal to, I have it in my notes here, I believe it's 86. Yeah, it's 86 degrees. Yeah. Okay, are we done? No, we haven't solved f yet, but conveniently we derived an equation earlier that gives f in terms of theta here. So let's just use that. We find then that therefore f is equal to 0.14 over cos of 86 degrees, which is equal to around 2. Okay. And I guess I think in the problem statement it was given in kilonewtons. Kilonewtons, yeah. 2 kilonewtons. Okay, so that's how I'd approach this problem. If you have any thoughts or comments, feel free to leave them in the comment section. Otherwise, thank you very much for watching.